So today we're going to do a pretty in-depth design tutorial. The software I'm using is Fusion 360, and we're going to be designing a fidget spinner. We start by creating a sketch plane with 5 construction circles centered at the origin. The outer circle is going to have a 2-inch diameter. Each ring will have 150 thou thickness with a 40 thou spacing. We draw arcs, concentrically constraining them to each ring and vertically constraining their endpoints. To make all arcs equal in length and in line, we horizontally constrain all top endpoints to each other. We can now make them all 0.6 inches in height by pulling a single dimension. Let's now connect the arches to create the ring profiles. We sketch and fully constrain a profile for the inner 2 rings, and create 2 arches and tongue and groove profiles for axial rotation. The top of this profile is a 1/4 inch with a 0.1 chamfer. Each of these arches has a 0.96 radius and a 12 thou spacing. To create the tongue and groove profile, we draw 2 parallel lines spaced 15 thou with tangent arches at the ends. Finish up this profile by tracing over our construction arches and constraining concentrically, and then mirroring all this over the horizontal line. Let's now sketch the profile for the pivot point to allow rotation between the 2 outermost rings. We make the inner cone 45 degrees with a height of 80 thou and a 10 thou tip radius. The outer cone is spaced with a 5 thou clearance at a 50-degree angle and a 12 thou tip radius. We can now turn our sketches into solids by revolving these 4 profiles around the origin z-axis. I like to create a couple of cross-sectional views. It helps a lot to visualize as we model. To constrain axial motion between the 2 inner rings, we revolve the tongue profile 10 degrees and create 8 instances with a circular pattern. Let's now create a new sketch plane on a plane perpendicular to what we have originally been sketching on. Start by projecting the intersection of these ring bodies onto our sketch plane. We are now sketching the same pivot profiles as we did before, but now between the 2nd and 3rd rings. Let's revolve these pivot profiles. The outer profile will be a cut, and the inner profile will be a solid body. And we'll do the same for the other ring pivot. We'll mirror both of these features to complete this step. At this point, you have a fully functional fidget spinner. Let's add some cool features to it. We create a new plane and insert an SVG of our brand logo. We remove the small text and add some reference geometry to help with centering. Use the patch feature to turn the letters into surfaces that we can move to center. Now that we have the logo where we want, we'll project this back to a sketch. From here, we can emboss our sketch into the body of the 3rd ring. We want to add the text to the other side as well, so we originally mirrored it, but realized it's backwards. So instead, we created a circular pattern of 2 instances. Finally, we'll add a knurled texture on the outer ring. We start by creating a line at a 45-degree angle that we will project to the surface of the ring. We create a new sketch on the bottom surface of the ring and draw a triangle, setting the size and depth we want it to cut the surface. We do the same on the top surface and use the loft feature between the 2 profiles, using the projected line as a guide rail. Rather than cutting, we create a new body. We mirror this body and then perform a cut. As creating a large pattern of a loft cut requires a lot of computing power, we instead create a pattern of the body cut we just performed. Now we have a nice knurled surface finish. To take it a step further, we define the joints and create a motion link. This is just a cool way to animate the model in your CAD program. Now we have a fully functional, super satisfying model of a fidget spinner. We have this for free on our website if you want to download the file and print it yourself.